Welcome back and thank you for joining me again. In this section, we will focus on the reciprocals of quadratic functions. Recall that the maximum number of intercepts that the graph of a quadratic function can make with the x-axis is 2. But in addition to this, we must emphasize that the quadratic function can have also only one x-intercept or no x-intercepts. The reason why we want to look into this is because when we reciprocate a function, the zeros of that function will turn into the vertical asymptotes of the reciprocal. So the maximum number of the restrictions then would be also equal to 2. So a quadratic function reciprocal will have a maximum of 2 restrictions or 1 restriction or no restrictions. So the maximum number of vertical asymptotes then will be 2, but it can also be 1 or no vertical asymptote. So let's begin with the reciprocals of a quadratic function with 1 restriction. Now, for this, we're looking into the graph of the function g of x equals x squared, which is the simplest quadratic function, and its reciprocal. And the graph that you see here on the grid is the graph of x squared. As you can see here, I've marked with a red dot the 0 of the quadratic function x squared. And we're going to start building the graph of its reciprocal by first reciprocating this very point right here. The y-coordinate or the y value is 0, which means that the reciprocal is undefined. And x equals 0 is a restriction, and this is where the asymptote, the vertical asymptote of the function will be. And we're going to label this by its equation. The vertical asymptote is at x equals 0. Next, we'll reciprocate every important point on the parabola. So you see that here the y value is equal to 1. The reciprocal of 1 will be also equal to 1. So this will be a point on the graph of the reciprocal. Now, at this point here, the y value is 4. So at x equals 2, the reciprocal will be 1 divided by 4. Next, we have at x equals 3, y equals 9 for the quadratic function. So at x equals 3, the reciprocal of 9 will be 1 over 9, which means that this point will be quite close to the x-axis. And if we continue to draw the graph at the right end of it, where the y values will approach infinity, then we're going to say that the y values will be 1 over infinity, which will be a number very close to 0, never equal to 0, but it will be above 0. So if we were to continue drawing the curve in here, then we would make sure to approach the x-axis without touching it. Now, next we want to check and see what happens between the vertical asymptote and this point right here. So what we're going to do is look at this point right in the middle when x equals 1 over 2. If x equals 1 over 2, the corresponding value of y will be 1 over 2 squared, which is 1 over 4. So when you reciprocate 1 over 4, we get 4 over 1, which means that at x equals 1/2, the value of y will be equal to 4. Similarly, we're going to say that when x equals, say, for example, 1 over 4, we're going to have the y value 1 over 16. So the reciprocal of 1 over 16 will be 16. So we're going to go all the way up here. So if we were to continue drawing this curve, this is what you would see. As you can see, the graph will approach the vertical asymptote without touching it. In a similar way, we're going to say that the graph will approach the horizontal axis, the x-axis, without touching it. And we know what happens, or what we call it, when the function will approach a specific value, right? But not passing or not having that specific value. So a horizontal asymptote will be formed in here for this end of the graph. So we're going to draw the horizontal asymptote right here. And the horizontal asymptote will be at y equals 0. In a similar way, we're going to reason about the next section of the graph. So here the y value is 1. You reciprocate it, we get 1. At this point, at x equals negative 2, y is 4. The reciprocal of 4 will be 1/4. Here we have x equals negative 3, y equals 9. The reciprocal of 9 will be 1 over 9 at the same value of x. So it's going to be a little bit lower right here. So if we were to connect all these points, as you can see, the y values will approach 0 but never become 0. So as the y values become infinity, because the graph is going up on the left end, then the reciprocal will be 1 over infinity, which will be practically equal to 0, but theoretically just a little bit more than 0, which will keep the graph above the x-axis because that's where the y values that are positive are located. So again, as the graph approaches the x-axis without touching it, we're going to say that this x-axis will serve as the asymptote, and it's a horizontal line, so it's a horizontal asymptote. So the horizontal asymptote for the entire graph is at y equals 0. Now, in a similar way, we're going to discuss what happens to the values of the function in this interval when you reciprocate this section of the parabola. So right here at x equals 1/2, the value of the function, negative 1/2, the value of the function will be 1/4. When you reciprocate 1/4, we get 4. So at x equals negative half, the y value will be 4. And similarly, again, as we discuss the right side of the parabola, we're going to say that as the x values approach 0, the y values are approaching 0. So 1 divided by 0.000001 will give us very large numbers. So in this case, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So it will give us 1 million. And that means that the function is approaching the vertical asymptote and getting bigger and bigger in the meantime. And what you see in here is the graph of the reciprocal of y equals x squared, or the graph of y equals 1 over x squared. So let's take a look at their features. So for the function g of x equals x squared, we're going to say that x-intercept is at 0, y-intercept at 0, vertical asymptote is at x equals 0, and horizontal asymptote at y equals 0. As x approaches infinity, y approaches infinity at both ends. And here we have, as x approaches infinity, the y values will approach 0 from above. And as x approaches negative infinity, 0 from above as well. Now, when x is approaching 0 from the right-hand side, the y values are approaching infinity. And 0 from the left-hand side, the y values are approaching again infinity. Now, when you talk about increasing and decreasing intervals for the parabola, we have a decreasing interval from negative infinity to 0. And we have a increasing interval from 0 to infinity. Now, for the graph of the reciprocal, you see that when this function is decreasing, the reciprocal is increasing. So that will happen for x values from negative infinity to 0. So that's an increasing interval. So we're going to put it down here. And the second section in here would be decreasing because the function itself is increasing, which makes the reciprocal decrease. So that would be from 0 to infinity. Now, in a similar way, we can draw the graph of the reciprocal of x minus 2 to the power of 2. Here is the graph of it. This time we have the vertex at 2 and 0. So that's where the graph of the function will show the y value of 0. And that's where the vertical asymptote will happen. And we're going to label this by its equation. Vertical asymptote is at x equals 2 this time. Now, we'll reciprocate all the points. So as you can see here, the point at this point, the value of y is 1, so it's going to stay 1 as well. The y value here is a 4, so that will become 1/4. The y value here is 9, so that will become 1/9. And the graph of the function will go close to the x-axis, and right here it will approach infinity. And in a similar way, we're going to discuss the other side of it. So 1, 1, the reciprocal, and then when x equals positive 4, when x equals 0, y is positive 4, which will make the reciprocal equal to 1/4, and then this is going to be 1/9. You connect the dots, And then the same thing happens with this section of the graph. It will increase to infinity. And the red graph that you see in here represents the reciprocal of x minus 2 squared. Or, in other words, the function 1 over x minus 2 squared. One last detail we need to add is the asymptote. Remember that the asymptotes are part of the graph and they transform with the graph as well. So y equals 0 is a horizontal asymptote. Now let's describe the features. We have x-intercept at x equals 2, y equals 0, and y-intercept here happens to be at 4. So the vertical asymptote is at x equals 2, and the horizontal asymptote is still y equals 0. Now, when we talk about the end behaviors as x approaches infinity for the given quadratic function, y approaches infinity at both ends. And in this case in here, as x approaches infinity, the y values are above 0. We call those 0 pluses. And the same thing happens when x approaches negative infinity. The y values are above 0. Now, as x approaches positive 2 from the right-hand side, then the y values will approach infinity. And as x approaches 2 from the left-hand side, the y values will approach infinity again. Now, when it comes to increasing and decreasing intervals, we're looking at parabola first. So it is decreasing from negative infinity all the way to 2. So negative infinity to 2, it's a decreasing interval. And positive infinity, positive 2 to infinity will be an increasing interval. Now, wherever the function is decreasing, the reciprocal will be increasing. So, because the reciprocal of an increasing quantity is a decreasing quantity, and we have discussed that multiple times in the previous videos. So, we're going to say 2 to infinity will be a increasing interval. Here we go. Decreasing interval right here. So, they're going to swap places. And negative infinity to 2 will be, again, from negative infinity to 2, we'll see an increasing interval. So this is a reciprocal of a quadratic function with one restriction. What if a quadratic function has two restrictions? So we'll look into this in the next video. Thank you for learning with me, and bye for now.